Hello and good morning to all of you. I welcome you to this series of lectures on big data analytics. Before I begin with the lectures, I would like a brief introduction about myself. I am Ajay Sharma, Associate Professor in Department of CSC at AGC Amritsar, with a total experience of 30 years and 22 years in AGC Amritsar as an educator, programmer, administrator, and any other role that enhances brand productivity. My areas of interest include programming, databases, big data analytics, IoT, machine learning, application development, etc. I'm in charge of the specialized lab in big data analytics in our college. I also have a YouTube channel with the name of Tech-Xpert, which I would like all of you to join so that you can view all the videos that I post there. Before I actually begin with today's topic, I would like to give you a brief introduction about all the things that we are going to study in this course. So, this course on big data analytics is divided into six CEOs. The first CEO as to understand ecosystem of Hadoop and Hadoop installation. The next CEO, CO2, is to understand about the Hadoop distributed file system and its usage in storage of big data. The third CO is to implement the HDFS commands for managing operations on huge files in a Hadoop cluster. CO4 would be highlighting the tools like Pig and MapReduce for analyzing big data. And CO5 would be there to explore various operators in Apache Pig for performing analytics. CO6 would be handling the various functions that we use in Apache Pig for performance analytics. Here is a detailed summary of all the things that we are going to learn in the various CEOs. So we'll be starting with an overview of big data and big data analytics, characteristics and properties of big data, the 7 V's of big data, the various big data sources. Similarly, we'll be configuring a Hadoop cluster, setting up a Hadoop cluster and configuring its various properties. And then we'll be discussing the Hadoop and its ecosystem. Also, since Hadoop runs on Ubuntu, we'll be learning all the Ubuntu commands like cat, pwd, mkdir. We'll also be going through the advantages and disadvantages of HDFS and the various daemons that the HDFS has. We'll be discussing about name node, secondary name node, and data node, about HDFS blocks, why the block sizes are huge in HDFS. Then we'll be learning the various Hadoop file system commands. A list is there on your screen. And then we'll be dealing with the analytics part of Apache Hadoop, that is the Apache Pig. And we'll be studying about the Pig architecture and installation of Pig and the introduction to the grunt shell and the various commands that we can run in grunt shell. And we'll be learning about the Pig operators and the functions in Pig, which would help you to analyze data. The datetime functions also will be learning, the math functions. And at the end, we'll be discussing a few case studies so that we can understand the real world scenario of big data analytics. So coming back to my presentation. So let's have an introduction to big data. So before that, we need to know what is data. Well, you see, anything and everything is data. We are surrounded by data. There is a data deluge in today's world. Now, where does this data comes from? It comes from everywhere. We speak, we move, sensors are generating data, computers are generating data, documents are generating data. We can classify this data either as structured or unstructured. Similarly, we can have the human generated data like emails, blogs, videos, pictures, etc. And we can have machine generated data like the automatic alerts, logs, and sensor data. So the thing is, what is big data? You'll find hundreds of definitions about big data on the net. I've chosen one standard definition for big data. Big data is a term for a collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. Now, what are these on-hand database management tools? See, we have been discussing RDBMS, the Oracle and the MySQL and the SQL Server, all the databases we have been studying. They are very good tools to analyze data, but they are not capable of analyzing huge amounts of data. They are not designed to analyze huge amounts of data. Okay, so this big data is everywhere. It's coming from experiments, from research, from photo sharing, from CCTVs, social networking sites, e-commerce sites, the point of sales terminals. This point of sale terminal is like whenever you go to some store, some like shopping mart, you see you insert your debit or credit card somewhere. So that particular point where you are inserting your debit or credit card for payment, that is known as a point of sale terminal. Now this data has been rising exponentially over the years. For example, if you see in 2007, we had 295 exabytes of data, and which like grew to 650 exabytes in 2010. Similarly, you can see the data projections. This exabyte is a unit of data, okay? And by 2025, it is an estimated 181,000 exabytes, okay? So just have a look at this data sizes, how they have evolved over a period of time. We were like dealing with MBs and GBs in the 90s. Then came the era of TB, terabyte, petabyte. Now is the time for exabyte, the zettabytes, yottabytes. You can see new terms have been coined for data storage because the data is really rising humongously, right? Now let's take a few examples of this enormous, huge, big data. Google everybody uses, so Google is processing about 45 petabytes of data per day. Facebook has 3.5 petabytes of user data plus 20 terabyte data per day. Just see the amount of data that is around us. eBay e-commerce website has 7.5 petabytes of user data plus 50 terabytes per day. Similarly, stock markets are generating 1.5 TB data per day. YouTube, which all of us are using every minute, I would say, YouTube, it's generating about 85K hours of data every day. So just see the amount of data that we are surrounded by. And these are the big data generators. I'm aware most of you are already aware of all these symbols that you see on your screen right now. So the facts in front of us are that the traditional systems are not able to store this huge data, and huge cost is involved in increasing the server capacity. Like if we really need to store this data, we need to increase the server capacity. And most of the data in the real world remains unprocessed. Now, approximately 90% of this data is unstructured, and enterprises are unable to process this data. So, what we are dealing with in today's world is unstructured data. It is coming to us like it is coming from everywhere. We are clicking pictures, we are scanning pictures, okay, we are creating selfies. So, we are creating voice messages. So, all this data is unstructured. There's no structure for this data. And the organizations, the enterprises, they are unable to process this data. So, what needs to be done? So we conclude that the huge amounts of data being generated nowadays needs to be, number one, stored properly, number two, processed properly and quickly, and more importantly, should be analyzed for business and enterprise growth. So the solution to this problem is the use of a software known as Hadoop. So we'll be discussing more about big data, its sources that generate big data, and the usage of Hadoop, the setting of the Hadoop cluster in some forthcoming videos that I'll be sharing with you. Till then, thank you very much.